Alrighty, welcome everybody who is attending live, and welcome to anybody who is watching the recording afterwards. My name is Tim Heng, and it gives me great pleasure to welcome you all to the current running of Excel Virtually Global 2022. This is a conference that has been going for about 8 years now. This is the third one that we have done virtually, and this year we have more than 30 hours worth of great presentations from a series of Microsoft MVPs, technology experts, teams from Microsoft as well, that hopefully you'll be able to enjoy over the next day and a half. If you have any questions, please feel free to get in touch with us via the website. If you haven't already realized, it is free. All the content is being provided by people who've very generously donated their time. So I would like to reiterate Liam's comment before that we would love you to make a charitable donation of whatever you think is a fair price for what you're going to be watching over the next 30 plus hours. The first session is actually going to be me. I'm going to be kicking it off. For the most part, we've recorded videos in advance, so you'll get to see me welcome you all again. Please feel free to interact with the Q&A. In general, we're going to have the presenters around to answer questions where possible. So without further ado, I will set myself going.
Hello everyone, and welcome again to my session on Excel Virtually Global 2022. My session today is going to be on Excel 2007 to Office 365. The motivation for this session comes from all the training courses that we run at SumProduct, where we work with a lot of people who have used Excel for many, many years. In fact, just last week I was running a training course with people who had used Excel for decades, but perhaps hadn't noticed some of the new features that had come out, either because they'd not attended a training course for a while, or they've just simply not been exposed to, different ways of working in Excel. So, with that in mind, this session is going to be basically focused on some of the features in Excel that perhaps get overlooked, where if you haven't had the opportunity to be introduced to the features, you might not notice that they exist and might not be able to take advantage of some of these tools. So, without further ado, we're going to try to cover some of the most useful features going all the way back to Excel 2007, and try and pick out something new from each version of Excel between then and the more modern Office 365. Alright, so let's look at the datasheet. I'll try and remember to post a link to this file in the chat, and certainly by the time it gets up onto YouTube, hopefully I'll be able to have a link posted in the comments, either in the comments or in the video information below the video. So, this datasheet has a table of data that you can see here. We can see that it has headings across the top, it has values going down, and this data set is about 1,000 rows long. Now, this is a pretty classic sort of data set. It's some transactional data looking at different sales and different amounts that have been paid associated with those sales. Pretty typical, all things considered. Now, what you tend to find is that people might run formulae over this data set where you might choose to sum up, for example, the amount invoiced. It might be that you try and run a pivot table over the entire table and try and summarize your data that way instead. There can be any number of ways that you might want to interact with this data set. Now, let's show you, I guess, how you might try and do that. If I were to click on this table and I go Insert Pivot Table, then what we'll find is that Excel will work out the range of the pivot table. It's going to go from F10, which is the top left-hand side, including the heading, down to M1010, which is the very last data point and the last column. This is a very classic way of using data and turning it into a pivot table. The problem with this generally arises when your dataset changes, and that dataset may change in several different ways. You might choose to add additional columns onto the right-hand side. You might find that your dataset goes to 1,000 rows in this case, and then next month we might extend that by another several rows. The big problem with this is that when you have a pivot table and it points to a specific range, what you'll need to do is to go back to that pivot table, and you'll need to manually update the data source to incorporate the additional rows or the additional columns that you've added to your data source. This is what we're trying to avoid, that manual process of having to update. It could be a pivot table range, it could be your sum range. If I were to take the total amount invoiced, I could take the sum of the values from L11 down to L1010. But as soon as I want to add on an extra 200 rows of data, I need to manually go through and update all of my formulae. Often the way we do this is to try and do a quick find and replace, where we go replace values of 1010 with 1210 or whatever the end row of the data might be. But that itself is unreliable. That relies on us, A, to remember to do that, B, to remember to, I guess, collect the correct number of rows, and C, hope that there isn't anything that actually has a value of 1010 in the worksheet that we don't want to update to a wrong value. So the question is, can we set this up in order to reduce the incidence of manual work to fix up the data when the dataset expands? The answer to this is yes, we can, most certainly, and it's through the use of a tool in Excel called tables. So often I joke that when we're trying to insert a pivot table, the first thing that we do to this dataset is not to go insert pivot table, but actually to go insert and then table. Let's do this now. If I click on table, this is going to take the dataset and identify for us what is the range of the table of data. In this case, again, similar to the pivot table, insert pivot table tool, it identifies the size of our table, which is great. In this sense, it actually identifies which the first row in our dataset has headers. Now, when we're creating tables, this is often done in one of two ways. Either it recognizes that the formatting in the header row is different from the formatting elsewhere in the table, and so it knows that the first row might be a header row rather than a data row. Secondly, it'll also look at the number formats in the table itself. So here it'll recognize that the amount invoiced, say, is a text item, whereas all of the items below it are numeric or currency format in this case. So as a result, it knows to identify that first row as being a header for our table. From here, I can hit OK. And this is now a capital T table. Alright, once we turn it into a table, there isn't really much that gives it away that it's anything different from what we saw in Excel previously. The cells all still look the same, the headers still look the same. The only difference is that the headers now seem to have an auto filter, or the filter tools that are attached to each column. And down the very bottom of the table, you might not notice this straight away, but there's a little sort of fill handle type thing in the bottom right hand corner, so just around that 15.05 in the bottom right. That basically tells you the end of the table, so that's the bottom right hand side of the table. So, what does having a table actually do for us? Well, if I were to try to create a pivot table again, I can click on the table and click on Insert and click on Pivot Table. Now, instead of referring to F10 to M1010, this now refers to Table 3, where Table 3 is the name of this capital T table. I say capital T table to distinguish it from what the average person looks at when they look at this. Remember we said at the very beginning, this looks like a table of data, but that's a lowercase t table. This is now a capital T table because we've defined it as a table in Excel. That means the headers are important, the rows are important, and Excel can define this range as being a named table. So first of all, the first thing we might do when we create a new table is to note that we have a new ribbon item, this Table Design tab. In the Table Design tab, the very first item on the left-hand side is the name of the table. So this might be something that we want to change in order to make the table more easy to recognize. Suppose here we're looking at sales, so I'm going to go ahead and refer to this as the sales table. Okay, so I can now create a pivot table off the back of my sales table. If I were to go to Insert Pivot Table, I can see that it's now pointing to the sales range. I can put this on a new worksheet, and this is now where my pivot table is going to be. I'll just create something really quickly by bringing the stores into the rows, I'll bring the items into the columns, and I will bring the amount invoiced into the values section. So there we go, we've got some basic information here. Now, here's where we see tables come into, I guess, their own. We said that if we were to create a pivot table, what we find is that when the data increases in size, the pivot table doesn't know to automatically pick up that extra row of data. So, if I were to come down to the very bottom of this list and start adding more information, I can see all of these dates are in the first half of 2019. So what I'm going to do is put in a new date here, 31st of March 2019. I'll put in some extra details here. This will be the South store selling a pentagon, which has 5 sides. Tim is a salesperson. We'll sell it to the same person that purchased something from Joe. And this will be for an amount of $1, $2, $3, $4, $5, $6. And how much was paid? You know what? I'm going to assume that 1, 2, 3, 4, 5, 6 was actually paid. So when I go back to my pivot table, if I right-click and refresh, normally this wouldn't change the pivot table because the pivot table would be fixed to the 1010th row. But because it's a capital T table, the capital T table expands automatically and increases in size when new rows are added. So with that new row in place, that will automatically get added to the dataset, which is fantastic. Likewise, if I were to remove that from the dataset and I go back and refresh my data, that will remove it from our pivot table as well. Okay, so that's on the rows side. Suppose I wanted to create a new column. I could go back to the top of my data and add in a new field for the amount outstanding. So the amount outstanding column is going to be a column that essentially takes the amount invoiced minus the amount paid. And so if I were to put a formula in this cell, that would normally be equals L11 minus M11. So I'll just do that here. Click on L11 minus M11. Now, those cell references didn't come up. Instead, I have these structured references. The first one says at amount invoiced. The second refers to at amount paid. Now, amount invoiced and amount paid pretty obviously refer to the amount invoiced column and the amount paid column. The at symbol essentially says when you're looking at that column, refer to the cell or refer to the row that is in the same line as this amount outstanding. Okay, so when I hit enter, here's going to be one of the other useful features of tables. It's not just a case that tables give you a formula that applies to any row in this table, but when you put a formula in place, it's actually going to extend all the way down the table. So I've got one consistent formula that applies across all 1,000 rows. And again, if I were to add in a new row of data, 31 March 2019, then that formula automatically continues onto those next rows that I'm adding on as well. This level of formula consistency is one of the reasons that makes tables really useful for managing your data, because it means that you can basically manage all of the formula in your table from the top. As you modify this formula, if I were to add on 50, that will add on 50 to all of the cells in the table. If I were to remove that, that will fix up the formula for all of the cells in this column. Now, when I go back to sheet 1 and I refresh my data set, again, remembering that a standard pivot table would stop at column M, because this is a capital T table, it's pointing the data set to the sales table. And the sales table now has one additional column. So when I click refresh, you'll see that in the right-hand side, we have one additional column that reflects the new column in our dataset. So, lots of good reasons why you would use tables. Pivot table aspect expands automatically, but more importantly, we've got this consistency of formulae. We've got structured referencing to make the references within a table easier to follow. But then finally, we've got structured referencing to make the calculations that refer to the table easier to follow as well. I'm going to scroll across to the right-hand side a bit, and let's create a new line off to the right for the amount invoice total. The amount invoice total is going to be the sum of all the values from the amount invoiced, L11, all the way down to the bottom of this table. So I'm going to use Control-Shift down to select all of the items in this table. When I do that, you'll see that the reference from L11 to L1010 has changed, and instead it's pointing to sales, square bracket, amount invoiced. I can close brackets and lock the formula in place. Now what's actually going on here, it's pointing to the sales table and then using the square bracket to say I am picking out the amount invoiced column from the sales table. If I were to type that in a formula, I can go equals sum, and instead of clicking on the table itself, I could actually just start typing in the name of the table, sales. And from there I can use tab to add it in from the list of items, the list of items and functions and named ranges and things that show up in my file. So tab brings me that table. You can see the little blue outline around the whole table itself. So when I point to the sales table, it's pointing to all of the data in the sales table. If I want to point to a specific column now, I can press square bracket and then start typing in which column it is that I want to get data from. In this case, it might be the amount. I can see the amount invoice has been selected in the list, so I can hit tab to pop that in, square bracket to close off the the particular field choice that I've chosen, and then closing normal bracket to close off the sum function as a whole. So in this way, we can use the structured references to refer to tables. The big benefit of this, again similar to pivot tables, is that when the data size changes, I don't need to manually go into my sum formulae or my lookup formulae or any of the other formulae that refer to the range of the data set. This knows to automatically refer to all of the items in the table. And so if there are 1,200 rows, it'll refer to 1,200 rows of amount invoiced. If there are 2,000 rows, it'll refer to 2,000 rows of the amount invoiced. It's going to refer to everything in the column. So this is a really nice way of ensuring that you don't need to perform manual tasks when it comes to updating your data set. So it's worth noting that tables have been around since about Excel 2007. It's a tool that a lot of people haven't necessarily run into yet. If you're attending this series, this conference, then you've probably run into this previously. But if you've stumbled across these videos at some point in the future, definitely do check out the use of tables and start to use them. All right, moving on from 2007, I might jump back to our pivot table, because this is a really good place to talk about the use of slices. Now, we often use filters in a pivot table. Suppose I'm trying to filter a pivot table based on a particular salesperson. I can set up the filter in the pivot table fields. I can specify then, using the drop-down list in the grid, that I want to choose Alice as the salesperson, and that will filter my pivot table accordingly. Suppose that I want to include multiple people. I can select multiple items and say I'll pick Alice and Chen. And these are the two people who correspond to these numbers in the pivot table. The problem with this is that it's not terribly user-friendly. So I've got Alice and I've got Chen in this, but because of the way the salesperson filter works, I can't actually see which items have been selected at any point in time. So I'm going to unfilter this list by putting everyone back into place, hit OK, and then I'm going to drag the salesperson out of the filter section because there are better places to put this. Instead of bringing it to the filters, what I'm going to do is right-click on the salesperson field in the field list, and I'll click on the item called Add as Slicer. Now, slicers, I believe, came about in Excel 2010, and they are essentially user-friendly filters. So a slicer gives me the ability to select one or multiple different salespeople and have my pivot table update automatically. If I were to control-click on Alice and Chen, then both items will be selected for the purposes of my pivot table. Alternatively, there is a multi-select option at the top of the slicer, and if you choose that, then any additional items that you select will automatically be added to or removed from the pivot table accordingly. And so in this way, this gives us essentially a user-friendly means of filtering your pivot tables, which also has the added benefit of allowing you to see all of the filtered items at any point in time. If you have filtered this and you want to quickly remove your filter, there is a Remove Filter button on the top right-hand side of your slicer as well. So slicers are really cool tools for the purposes of creating interactive dashboards, essentially. If you can set up a pivot table and a pivot chart, you can basically use slicers to control these, and that's a really nice way of working with your data set. Now, if you were to copy and paste your pivot table, and so if I were then to, say for example, remove the items from the list and drop in the number of sides instead, what we'll find is that clicking on a particular slicer is also going to filter the pivot table that was copied from the original pivot table. However, if I were, instead of creating a pivot table that way, if I were to create a brand new pivot table, I'll go Insert, Pivot Table. I'm going to put it on the existing worksheet for Sheet 1. Drop in some data here. So let's do exactly the same pivot. Store on the left, item in the columns, sorry, not the item, the number of sides in the columns, and the amount invoiced as the values. When I filter using my slicers, you'll note that this only filters the first pivot table. It doesn't filter the second pivot table. And so often the challenge becomes, how do I make sure that my slicer is connected to all of the pivot tables and pivot charts that I might want it to? Well, if I click on the slicer, I can click on the slicer tab that appears when I select a slicer, and the item that I want to choose is this Report Connections button on the top left-hand side. Clicking on Report Connections allows me to see which pivot tables and pivot charts are actually connected to this slicer. And you'll see that Pivot Table 1, which is the one on the top left, is connected. Pivot Table 3, which is the one that I've just created, is not connected. If I do want them to talk to each other, then I can tick the box, hit OK, and you'll see that the new pivot table now adapts to changes in values based on my updated slicer. So hopefully you can see this is how we can create these interactive dashboards, where sometimes we want some charts or some parts of our report to update in line with the filter selections, and perhaps there are going to be other times where we don't want the numbers to update because we want the numbers to work on a whole portfolio basis instead. Alright, some other factors that we can use with slicers. If I add a slicer for the customers over here, you'll see that there are a lot of customers in this list. It might be quite difficult to have to scroll up and down to look through all those different customers. So if I were to expand this out, what you'll find is that by default, the slicer only reports items one column at a time. But there are some settings for slicers that allow you to circumvent that. So again, if you click on the slicer heading while you've got one slicer selected, you'll see on the right-hand side, you can customize the number of columns that appear. So for things like customer IDs, maybe I might have 1, 2, 3, 4 columns, which makes it much easier to scroll through this list because I don't need to scroll quite as far. So this is a nice way of using slices as well. Now, there is yet again another new feature that came about not in Excel 2010, but in Excel 2013, I believe it was, which is the timeline slicer. Now, this works if you have a date specifically, and so one of the fields we have in our data set happens to be a date field. If I right-click on this, I've got the option to add a slicer, but you'll see that a slicer with a date field isn't terribly useful for us. It basically contains all the individual days that exist. Because, again, that's how slicers work. They give you one button for each item, or each unique item in the column that you're referring to. So I'll remove that, and instead, I'll right-click and click on the Add as Timeline button instead. Add as Timeline gives us a date period that we can use. And so if I look at all of our data, which is generally between January and July, this is the full data set. Instead of using January to July, maybe I want to look specifically at January through to February. And so I can select the January to February range, and that will filter the pivot table accordingly. Suppose I want to look at April to June. I'll select April to June, and again, that will highlight the April to June sales in my pivot table. Now here's the best bit. If I want to zoom in, instead of looking at it on a month's basis, suppose I want to look at it on a daily basis. This gives me the ability to get some really granular data in place. Say if I want to look at the specific week from the 27th of May to 7 days after that, so that'll be the 2nd of April. I can shift click to get my 27th of May through to 2nd of April, and this is now 1 week's worth of sales for my pivot table. Again, much the same way as the slicer, if I were to click on the timeline part of the ribbon, I can also click on Report Connections to hook it up to the second pivot table on this page. So slicers, timelines, these are really useful tools in order to make a report or a dashboard really dynamic and make them easy to use. Because the ability to just reach out and tap them on your touch screen to choose specific filter items, it's so much more user-friendly than having to click on the little arrow to drop down and filter things on the page itself. So it's not just pivot tables that have access to these slices, but it's also capital T tables that have access to these as well. If I were to click on this table, I can go to the Table Design tab, and there is an Insert Slicer button, which allows me to very quickly create slices for, say, the store, the item, maybe the salesperson, hit OK. And so this gives me a series of slices that I can maybe line up at the top of the page. I'll just put these at the top of the page here. We'll just move these in place. And by having these here, I can then very quickly filter my table to items specifically relating to all three of these slices being applied at the same time. Now again, this is basically the equivalent of going to one of the filter buttons in the table itself and filtering based on east, north, south, west. The difference, of course, is, as I mentioned before, filters are a little bit finicky, and slices, on the other hand, are very user-friendly. So we've got the ability to very quickly just reach out and pick specific items that I want to include, or I can clear the filters to exclude them as well, and reset the data back to the original position. Unfortunately, there are no timeline slices attached to tables, just standard slicers. So if you did want to see a timeline slicer attached to a table, to make sure you provide that feedback to Microsoft, and if there's enough people who want that particular feature, they may look to try and implement it in the future. Alright, well that's it about tables, timelines, slices. We're up to Excel 2013, so it's about time that we moved on to Excel 2016 and some of the more modern versions of Excel. So let's move on to the waterfall chart then. Waterfall charts are great charts that help you work out how things move from one position to another position. So in this case, as an example, we have the budgeted profit, which is essentially the initial base profit that we had of 123,000 that we budgeted, and an actual profit of 190,000. And so we basically want to see how do we get an additional $67,000 in profit, and how does that, I guess, flow, or how does that come from the 5 different categories that we have here of income, payroll costs, vehicle fleet, operational costs, and other costs. Looking at the differences, we can see that there is a $76,000 improvement in our P&L that came from income. There's a $25,000 hit to the P&L that came from payroll costs. An additional $8,000 hit in vehicle fleet, but we also saved $45,000 in operational costs as well. So factoring all these things together, how do we go about showing this on a nice user-friendly interface? This is where waterfall charts come in. Now, waterfall charts used to be quite difficult to build in Excel. In Excel 2013 and earlier, you would need to have a clustered column chart or some sort of other fancy column chart that had various stacking bits. You used to need the bits that go up in one color, the bits that go down in another color. You'd need to have floating bits that would force the green and the red bits to sit at different heights. Nowadays, it's much simpler. I can basically just select the categories and the chart data. And if I go to insert, you'll see in 2016 and onwards, there is a new waterfall chart type that exists here. And this is a different, this is a chart that doesn't exist in Excel 2013 and earlier. If I select the waterfall chart, you'll see this produces a basic chart that we can use. I'm just going to increase this in size so we can see what's going on. Now, by default, Excel will assume that every item in the chart is something that increases or decreases the waterfall, and that you will need to basically reset the value for the next point at the end of the previous point. Now, it may be that that's not actually the case. For example, the actual profit at the end of the day isn't something that sits as an increase above the previous other cost line item. But instead, the actual profit is the total at the very end of our waterfall. So in order to modify this and let Excel know that this is actually a total, we need to click on the data series and then click one more time to select specifically the actual profit. From here, I can right-click on this and set as the total. Likewise, for the budgeted profit, I'm also going to right-click on this and set that to be a total. In this way, I can see that we started off at 123,000 and income increased it, payroll costs and vehicle fleet decreased, operational costs increased the figure again, other costs decreased it, to come to a running total of $190,000 worth of profit. So this is a really nice, easy way to create waterfall charts. In the old days, back in Excel 2013 and earlier, this might have taken an hour perhaps, or half an hour to set up in order to create all of the different formulae and categories that you need to allow some of these bars to float up in the air. Generally speaking, as I mentioned, you would have a stacked column chart. So you would have, say, this blue item that was increasing, but then you would also have a red item that would be 0 in that period. And then you'd also need an invisible floating item to get it to hold up at that point and start off from the value in the column prior. But Excel does all the heavy lifting now, and so all we need to do is insert the waterfall chart and then just make sure that we have the data lined up in a way that works for the purposes of building these waterfall charts. We then go through and identify the total columns just so we can pop those into place and show the waterfall chart going from one total column to another total column. And there you have it. Waterfall charts in Excel 2016. We're now coming up to what many people consider to be one of the most amazing new improvements in Excel, and that is the use of Power Query. So Power Query is in the Data tab, where we can see on the top left-hand side, we've got this ability to get and transform data. Power Query is the collective term that we use to refer to all of the features that are in this section, where we can get data from a range of file sources, database sources, from the Azure systems Power Platform like Power BI and data flows and so forth, different online services like SharePoint, like Microsoft Exchange and Salesforce, as well as many other sources. And if you've got some sort of proprietary database in your organizations, what you'll tend to find is that you can either get an OData feed or an ODBC connection into the server accordingly. For our example, we're going to use from file looking at from folder to showcase some of the abilities that Power Query has. If this isn't intended to be a deep dive into Power Query, this is simply to show you some of its features and to show you how cool it is. There should be many other sessions on Power Query throughout the rest of Excel Virtually Global, so don't feel like you're missing out. Do make sure you check out some of those sessions accordingly. So we'll get data from a folder, and I'll just need to select the folder that I want to pull my data from, which in this case is called PQ Standard Expenses. Now in this folder, there are a series of 10 CSV files that I want to get my data from. If I want to combine the data in these 10 files, I can click on Transform, which will open up the Power Query window and allow me to start filtering our data set and choosing which files I actually want to include. Now, it might be that I need to filter this dataset to only include the CSVs, because one thing about Power Query's get data from folder is that it doesn't just pull up a list of all the items in this folder, it also pulls up a list of items in all of the subfolders underneath this folder as well. And so it's going to be important to filter out the dataset to only include the items that we need before we combine them on the left-hand side. So I can click on this little Content, Combine Files button, and what Power Query is going to do is it's basically going to identify what is a standard CSV format in this case. We've got a series of expenses, it's got headings, and so Power Query behind the scenes is going to set up a function or a rule that says take these files, promote the headers, and then combine the files together in this list. And so here I have a I guess my combined list of 10 files with all the data that I have that I need. Now the big benefit of Power Query is the fact that it's going to complete these steps next time when I try and refresh the data. And so if I set up a series of data cleansing steps here, so I can look at Derek Stand, Sarah Boss, and Mary Wells. In this case, I want to apply these names against all of the rows underneath. Well, I can clean this up quickly. I've got some spaces there or some blank cells there, so I'm just going to replace the blanks with some actual blank cells, what Power Query considers to be blank cells, called nulls. And then I'll take that column and fill it down so that each name populates against all the other rows that are associated with that particular file. I can see on the right-hand side I've got amounts that are in pounds rather than in dollars. And so what I might do is convert this from text, because my local version of Excel doesn't recognize the pound symbol. So I will, using locale, convert that from a currency type in the UK to the currency for Australia. Now, I'm letting Excel know that the original data is in a United Kingdom locale, so it recognizes it will then recognize that the pound is just a currency type and should be removed. So when I convert it over, it now recognizes that the pound is removed. We're now treating these as dollar figures. And then from here, what I can do is just remove all the empty values so that I've got a clean data set that I can load into Excel. So if I go to Home, Close and Load, then Excel will have completed the task that I asked it to do, which is to take these standard expense files that are located in this folder and drop them in. So I've got 51 rows that have been loaded into Excel. Now the advantage of this is that I have 10 files in this folder. And if I were to increase the files in this folder, say from 10 through to 20 files, then what's going to happen is that if I try and refresh this query, Excel is going to need to pick up all the files that are in the folder, all 20 files, and combine them together again. And so if there's 51 rows here at the moment, there should be 102 rows in the final database. So what we're going to do is click on the table, and I can go to Table Design and click Refresh, or I can go to the Data tab and click Refresh All to update all of the queries in my file. So by clicking Refresh All, I can see very quickly Excel has gone to that folder. It's picked up all of these new files as well, the copies in addition to the original files, and appended them all together to give me my output, which is now 102 rows. And I'm sure you can imagine, as I increase the number of copies that I put in the folder, we're all going to have a much larger data set that incorporates all of those additional expenses accordingly. This is the value of Power Query. It's really useful. It's really great to automate all of your data manipulation tasks. It remembers all of the steps that we took. So, for example, to fill Derek's name down in each of these sections, to convert it from pounds into actual dollar figures. These are steps that would otherwise need to be done manually in Excel, but can be automated through the use of Power Query, therefore saving you time each month whenever you're updating your reports. Most importantly, when the data actually lands in Excel, you'll see that the data has landed in a table, capital T table, which means that when I refer to the results, I can point to the to values in the table. By the way, if you want to select everything in the table, you've got a couple of options here. You can either click just above the heading to select everything in the column, or what I like to do, I like to just click somewhere in the columns that I need and then hit Control Space. So Control, then the space button, in order to select the entirety of the column. And so because it lands the data in a capital T table, we can use our structured references to point to all the data. It can expand automatically when there's new rows in the data set. And overall, this is just a very nice, clean way of being able to build your reports off a moving data set that's going to change over time. All right, the last thing to go through is a combination of things, actually. The main topic I want to talk about is in the Office 365 releases, or what's come out in, I guess, Excel 2021 now, which is the topic of dynamic arrays. But before we get to dynamic arrays, we need a little bit of data. And so what I'd love to be able to do is to create a data set to work with. So I'm going to move over to the Analyze Data tab to get myself a data set. Now, let me just close the Queries and Connections window for now. The thing I will note is that this is a blank sheet. And the reason I wanted to start with a blank sheet is because there is a feature in Excel called Analyze Data, which you'll find on the Home tab. Now, Analyze Data is usually a tool to look at data that you might have stored in a table and to be able to look for insights and suggest different analyses that you can use to overlay on top of your data. But the second advantage of this is that if you don't have any data on your worksheet, it will suggest some sample data for you. And so if I need some dummy data and I need everyone to have a consistent amount of dummy data, then what I'll use is this Analyze Data tool, try sample data, because we get a standardized set of data that is just built into Excel. This is something that I think everyone gets. It's exactly the same data if you were to open it up on multiple different machines. So it's really useful for training, honestly. But in terms of how Analyze Data works, you'll see that the Analyze Data pane pops up on the right-hand side. And Analyze Data essentially suggests different pivot tables or pivot charts or even normal charts in order to, I guess, describe your data in ways that perhaps you might not have identified previously. And so if you see something that you like, you can click on the Insert Chart or Insert Pivot Chart item, and what that will do is either put a chart onto the worksheet, or it will create a pivot chart and pop that onto a new worksheet in your file. And this gives you the ability to simply look at your data in different ways. The other cool thing that you can do about in Analyze Data is to ask questions about your data. And so you could ask a question such as, show top 5 rating products. and what it will do is calculate the average ratings for different products and present the top 5. And I can insert this as a pivot table to give me the answer. Actually, it's given me the top 6, but you know, that's okay. I'm not going to fuss too much about that. All right. Oh, I see. It's given me the top 5 because that's tied. Excellent. Okay, so what was the point of this? The point of this exercise was A, to show you what analyzed data could do, but B, to create a set of dummy data that we can use for the purposes of demonstrating dynamic arrays. Now, dynamic arrays is one of the big, I guess the biggest calculation change in Excel since it was released. The idea in old school Excel, and I'm thinking Excel 2019 and earlier, is the idea that you have a function or a formula that you might put into a cell, and you wouldn't be able to refer to, say, 10 rows worth of sales. You would need to aggregate those 10 rows and bring it back down to a single value that you could put into the cell. And so in old school Excel, if you did something like this, it would generate an error, a hash value error. What it would force you to do is to sum those items instead, which would then convert all of those 10 items into a single item, which could be put into the cell G3 in this instance. Now, in modern Excel, this has changed. The paradigm of one formula equals one cell value no longer applies. Instead, we have what we call dynamic arrays. And what this does is it allows us to point to a range of cells. I'll use the same 10 cells that we had before. But instead of aggregating those results to be a single value, we can actually just refer to those 10 results and have them populate a 10-cell range, being each of those results one cell at a time. Now, this is a really big shift. The idea that you can have one formula that gives you multiple answers spread across multiple cells, that is a game changer when it comes to Excel. And we'll show you why. There are a lot of features in Excel that normally you would have to do via very manual processes. So for example, one thing that a lot of people try to do is to get a unique list of items. So if I was to try and identify the unique list of categories here, what would generally happen is that we might copy the column of categories and paste that over on the right-hand side. And then from here, we might select the range of cells and then go to the Data tab, hit on Remove Duplicates in order to, let's see, well, my data has headers, so we'll remove the category label. And that will condense down the results so that there are precisely 4 items, 4 unique items in this data set once you get rid of all the duplicates. I'll just bold the category heading so we know it's different. Moving forward, in Office 365 land, this changes dramatically. Instead of manually running this remove duplicates task, which you would need to rerun whenever the data gets updated, instead there is a new function in Excel. And this function is called the unique function. The unique function allows you to point to a range of cells, such as the category over here, and this will return for me a unique list of categories. This is dynamic. This is, well, I guess it's 2 parts. It's an array because the result of the formula is giving me something that spills over 4 rows. So n rows or y columns. That's your array essentially. It's more than one cell. But it's dynamic because if I were to take one of these items and relabel this to be apparel, then you'll see that the list of categories on the right-hand side has increased in size automatically to reflect the fact that I have one new item in here, the apparel item as well. This is fantastic. This allows me to have a dynamic set of calculations that keeps updating as my data updates. And of course, because my data is stored in a table, the functions that are giving me these unique results are automatically going to expand in size as there's new data. Now, it's one thing to be able to have a single function that points to this list. Second thing is, how can we actually use this? And so if I were to look at the total sales for each of these items, I might use, for example, a SumIfs function that says, let's look at all of the sales and let's find the sales that match up with this particular category. So I've got SumIf of sales based on the category, and so I've got this many sales for each of these categories. Now, this problem with this is that this is not dynamic right now. If I were to change the apparel back to clothing, then what you'll find is that my sales number changes. It doesn't actually pick up all the values that it might need to. It doesn't change in size. It doesn't reflect the fact that there are only 4 categories now. So it would be nice if, instead of pointing to just the components, I could teach the SumIf to point to all 4 of these categories. And that's what we can do. This introduces the notion of the spill operator, which is this hash item. What that does is it converts the reference to hash2, or h2, sorry. Instead of referring to h2, it refers to all of the cells that are spilled out from the formula that sits in h2. And so it will basically take each one of those categories, apply them one at a time into my SumIfs function, and return for me the results for, in the case of 4 categories, it'll give me 4 sets of SumIfs. If there are 10 categories, it will give me 10 sets of SumIfs. From here, I can hit enter to load all that into Excel. Now, it doesn't quite give me the answer that I want. It's giving me a hash spill error. And a hash spill error is one of those new errors that exists in Office 365. It's telling us that when we try and expand out the spill range for the sales, it's crashing into other populated cells in our worksheet. It's just like the pivot table errors that we used to get, except it doesn't actually override the other cells. This time it gives us a warning that there are other cells in the way. And you can see it's given us a little blue dotted outline to show us where it wants to produce the results. Once we remove the offending cells that are in the way, this SumIfs will calculate automatically. And if I were to replace this with apparel again, you'll see that that increases both the category size as well as the sales size. Now, one final thing we can do very quickly here, we can combine a couple of these ideas along with some other tools. So if I were to take a unique list of the categories, suppose I want that to be in alphabetical order. Well, I can wrap this in a sort function so that after I take the unique list of categories, I've got those 4 items, I can sort them in alphabetical order. Suppose I did the same thing for the year. Again, I can take the unique list of years, I can sort this in numeric order, and suppose I want this going from left to right. Well, we would normally paste transpose that in Excel if we were to copy paste values. In this case, there's actually the function now, transpose. Transpose has actually existed for a really long time, but you always needed a Control-Shift-Enter array to get that to work. Now, in dynamic arrays, we don't need Control-Shift-Enter arrays anymore. They just work. It just calculates automatically, and it spills across these 3 columns in this case automatically. This kind of looks like the setup for a pivot table. And so this allows me now to do a SumIfs that looks at the sales when the category is equal to my list of categories, and when the year is equal to my list of years. And just like when my sales initially were copied down the column for each of the categories, by having it both across categories and across the years, this is now going to give me a 2-dimensional dynamic array that spills across both axes of my little mini pivot table here. So dynamic arrays are a fantastic tool that you can use to enhance the way that you do your reporting. This kind of does away with your basic pivot table. You can create very nice bits of analysis that are automatically updating, that don't need manual refreshing, that give you the answers very quickly. So dynamic arrays, really great tool to use. So with that in mind, that brings me to the end of this presentation. I'll be around to answer questions at the end of this session, so please feel free to pop questions in the Q&A chat. Please make sure you fill out the feedback surveys that come about, and I hope you enjoy the rest of the next couple of days, as there are plenty of great presentations from not just other MVPs, but also Excel experts around the world and some team members from Microsoft as well. So look forward to having you and welcoming you to the rest of the conference, and I hope you enjoy. Thanks, everyone.
All right, and thank you to myself for running that session. We've only had one question during that presentation, which was something about dynamic arrays, wondering what would happen if we tried to make column H and column I in that last example a separate table. Trying to combine those dynamic arrays and tables, and I think this is the only place where some of these tools do fall over. Unfortunately, you can't put a dynamic array into a table. When it spills, it simply doesn't work, and when it'll try to populate the entire column with all of these dynamic arrays, which are all trying to spill, and so Microsoft hasn't quite got that to work. So it's a bit of a shame, but hoping that the team at Microsoft can try and overcome that in the future at some point. All right, if there's no other questions, then I might put up for now. We'll come back in about 4 minutes' time at the top of the hour